Hello, welcome back to another class. Today we will be doing about standard integrals. So we had learned about integration by parts, all right? And also we had seen some formulae involving the integration by parts. Today we will learn about standard integrals. Again, these are the things that you had done in your lower classes, but let us just have a look at what they are. Okay, so you have 9 of them. Okay, these 6. Okay, so basically, all right, it is when you are having a squared plus x squared minus a squared, or a squared minus x squared. All right, and if you see, they can either have the square root below, all right, or they cannot have any square root and that are involved. Okay, so these are the standard integrals. These can be easily derived, okay, some of them by integration by parts, some of them by doing some readjustments, or some of them by substituting tan theta or sine theta, okay, depending upon the cases. Okay, I won't be doing any of the derivations for these formulas, but you will have to remember them anyway. So these are the 6, and these are the other 3. Okay, so just have a look at them. Today we will be doing exercises based on these standard integrals. Okay, so 9 of them, right? So this one actually 6, 7, 8, and 9, these 3 of them have the integral sign on top. What I mean, have the square root on top. Okay, so keep that in mind. So if you have an integral like this, okay, for example, integration dx, okay, suppose we are having 5 squared minus x squared, okay, or let us make it a bit difficult, okay, so that you will see exactly what we will be doing. Suppose when we are having 5 minus x squared, you notice that it is of the form, okay, form number 6, okay, dx a square minus x squared, and you have the root below. So this one you can just write it like this, square root. You have to convert this one into a square, so you will write it as root 5 square minus x square, and then you can just use formula number 6 below, which is sine inverse x by a, but a it is root 5, so plus c. Okay, so you can just write it like this and it will be all right. Similarly, if you have something that looks like this, dx upon root over, let us say, okay, maybe let us keep the root on top this time, okay, minus 2, or x squared minus 2, okay, and you are having it like this. So you can easily write it as integral x squared minus root 2 whole thing square dx. Okay, and if you do this, okay, you will notice that this one has a resemblance with formula number 8. Okay, so you can just employ formula number 8, which is equal to x upon 2 root over x squared plus I think it should be minus. Okay, so minus root 2 whole thing square. I think I mistype formula number 8. Okay, it should be x squared minus a squared. All right, minus a squared by 2 log x plus root over x squared minus a squared. So you can simplify down the answer like this and it will be all right. Okay, so just correct formula number 8. It should be x by 2 root over x squared minus a squared. Okay, so you can do some corrections, and now we can proceed to the next one. Okay, so if they are of the types that are given by formula 1 and formula 2 3 4 5 6 and 7 8 9. Okay, you can easily do them like this. Okay, but what if, okay, they are a bit different. If you notice the formulas, okay, they are always like this: a square plus a square, or a square minus x square, or a square minus x square. Okay, but what if there is a term containing only x? Okay, for example, maybe like this: ax squared plus bx plus c. Okay, what happens if this one occurs? Okay, so what I'm saying, if you notice formula 1, okay, if you notice formula 1, 2 and 3, they have no square root. Okay, and in the denominator you are having a quadratic. Okay, not exact, okay, a quadratic, but no x term is involved. Okay, you are only having a square and a constant square. Okay, but there is no x term. Okay, x power 1. So that is why today we will be discussing integrals of the type, okay, where we are having root over dx by quadratic, or okay, so whenever you are having dx by quadratic, or you can even have dx by root quadratic and root quadratic dx. Okay, so if you see this one, it is actually similar to 1, 2 and 3. Dx by root quadratic, it is similar to formula 4, 5 and 6. We just have to do some modifications, but I will tell you in a moment. And this one, it is similar to 7, 8 and 9. Okay, remember that a quadratic, it is of the form ax squared plus bx plus c. Okay, so whenever you are having dx by this, okay, for example 2x squared plus 5x minus 1, okay, then you will have to use the rule that I will specify over here. And the rule is, okay, complete the squares. Okay, so we will have to complete the squares and then perform the integrals according to the formula. Okay, let us see an example. Suppose we are having integral dx. Okay, I will keep a quadratic over here, maybe 3x squared plus 2x minus 1. Okay, so this one, it is a quadratic. We know the rule, we have to complete the squares. So the solution, I will write this one as I. What exactly I will do here? Okay, first of all, I will take common the coefficient of x squared. Okay, so I will take common 3. So you will be left with x squared plus 2x by 3 minus 1 by 3. Okay, and this 3 now becomes a constant, so I can take it outside. Okay, I will write it again. You can actually skip a few lines if you are comfortable. 1 by 3. What should I do next? Okay, now comes the part of completing the squares. And for that, I will have to use the formula a minus b whole thing square. Or I will have to use the formula a plus b whole thing square. Okay, but which of these formulas do I need? It depends on this term containing x. So over here it is a plus, so we know that we will have to use this formula. If over here it is minus, then surely we will have to use a minus b whole thing square. Okay, so with that being said, let us just go ahead. So this one, this x behaves as your a, so x squared. You notice over here we have to use this formula, it has to be 2a, so plus 2, but a is x. Okay, so 2x Now we need 2x by 3, so I will write over here 1 by 3. But if you use this formula, you will be needing b squared, so 2ab, so plus b squared. Okay, so this is the extra term that we have added. X squared, it's this. 2x by 3, it's this. 1 by 3 whole squared, it is an extra term. So we will have to minus the extra term. Okay, but then this minus 3 will also be here. Okay, so this one, it's like you are just adding and subtracting the same thing. Okay, which won't differ in any way. Okay, which won't change the solution. So after doing this, I will write over here 1 by 3 dx. Now I will combine from here to here, and I will be having x plus 1 by 3 whole thing square. Over here I will be having minus 1 by 9 minus 1 by 3. I will combine them together, and let's see how much I will have. Okay, so minus 1 by 9 minus 1 by 3, you will be having, okay, 9 minus 1 minus 3, so minus 4 by 9. Okay, so now if you see, it has become into something that looks like equation 2. Okay, if you see equation 2, right? But this one has to be converted into a square. So I can easily do this. 2 by 9 whole thing square. Okay, so if you use formula 2, 1 by 3 will be here. Instead of x, you are having this whole thing. Okay, and instead of a, you are having 2 by 9. Okay, so the value of a, it is 2 by 3. The value of it is 2 by 3. So just use formula number 2. It will be 1 by 2 a which is 2 by 3 log x minus a, but instead of x I am having x plus 1 by 3, x minus a divided by x plus a. Again, I repeat, instead of x we are having this whole thing, and instead of a we are having this, and we are just using the formula. So we will be having 1 by 4 if you do the simplification. So 1 by 3 minus 2 by 3 will give you, okay, if you do the simplification, it will be like this. (3x plus 3). Okay, so this is what we are having after doing the simplification, plus c. All right, so just to be more comfortable, I will do another problem. Okay, maybe this time I will let it to be, okay, root over, okay, let us say minus 2x squared minus, okay, plus 5x plus 4 dx. Okay, so this one, it's also a root quadratic dx, so we will have to use that rule. That is, we will have to complete the squares. How exactly will we do that? We will take common minus 2 first, but minus 2 is inside the root, so we will be having minus 2, and over here we will be having x squared minus 5x minus 5 by 2x plus 4, it will be minus 2. Okay, if you take common minus 2. Okay, this minus we will keep it as it is, but root 2 I can take it outside. Okay, so I will be having only minus x squared minus 5 by 2x minus 2. Again, I'm keeping the minus outside of the bracket. You will see why. Okay, so root 2, I'll keep it outside. Root over, okay, a very big square root minus. Now we will use the formula a minus b whole thing square equal a square minus 2ab plus b square. Instead of a, it is x. So we will be having x square minus 2a. Okay, 2a. A, it's x. And I should get minus 5 by 2. So I will be writing over here, okay, 5 by 4. Okay, because 2 into 5 by 4 will give you 5 by 2. Again, I repeat, 2 into 5 by 4 will give you 5 by 2. So this one, it's 2ab. But if you see the formula, I will need b square. A square minus 2ab. So over here will be plus b square, which is 5 by 4 whole thing square. So this is an extra term. I have added it. Now I will subtract it. But also there is this minus 2. So minus 2 dx. So root 2. Okay, again, I'm having the square root minus. So from here to here, I can combine it. And I will be having x minus 5 by 4 whole thing square. And this one, if you simplify, you will be having minus 25 by 16 minus 2. So you'll be having minus 25 minus 32 upon 16. So you'll be having minus 57 upon 16 dx. Okay, so once this is done, okay, now multiply again the minus back inside. You will be having root over 57 by 16 minus x minus 5 by 4 whole thing square dx. So if you see now, this one, it's actually similar to number 9. Okay, if you see number 9, which is a squared minus x squared. Okay, so it's similar to number 9. Okay, I'll keep it there so that you can see. Okay, a squared minus x squared. So you can write this one as root over 57 upon 4 whole thing square x minus 5 by 4 whole thing square dx. Okay, and you can use formula number 9. Okay, by using that formula number 9, you will be having root 2, it's always outside, and then you will be having x by 2 root over a square minus x square. Okay, so this is what we will be having, a square minus x square root 57 upon 4 whole thing square minus x square, which is now x minus 5 by 4 whole thing square, and then you will be having plus a square. It is this, so 57 by 16, a square by 2, so 2 times 60 sine inverse x, which is x minus 5 by 4 upon a root 57 upon 4. Okay, you can leave the answer like this also, will be all right, or you can simplify, depends on you. Okay, so this is, okay, the answer plus C. Okay, so once you have those root quadratic, all right, root quadratic or 1 by quadratic or 1 by root quadratic, you can just complete the squares. Okay, so that is one of the types of integrals that we are discussing. The next one that we will be discussing, okay, so over there you were having only a quadratic, but what if you have a linear? Okay, let us write this one as type 2, and you have a linear polynomial in the numerator. Okay, so what happens if you have linear by quadratic Number 2, what if you have linear again in the numerator, and if we have root quadratic in the denominator? Or what if we have number 3, linear and root quadratic? Okay, so how exactly will we solve this? I will just write one line by adjustments. Okay, look at the derivative of the quadratic. Okay, so differentiate the quadratic and then you will do some adjustments after looking at it. Again, what is a linear? A linear is of the form ax plus b, and a quadratic, it is of the form ax squared plus bx plus c. Okay, so whenever you are having any of these, all right, you will have to do adjustments by looking at the derivative of the quadratic. Okay, so let's see number 1, an example. Okay, I will write linear. Okay, let us make it simple, 2x plus 1. So this is a linear polynomial divided by a root quadratic. Okay, let's see. Okay, minus, okay, let's make it, okay, let us make it a minus sign. Okay, minus x squared plus 5x plus 1. Okay, so let's see. How exactly will we do it? Again, the quadratic. Okay, I will substitute it from the very beginning. Okay, 5x plus 1 equal z. Okay, now differentiate it. If you differentiate, you will be getting minus 2x plus 5 dx equal dz. Okay, so this is what we will be having. Now, how exactly should we do the adjustments here? Okay, the numerator should contain minus 2x plus 5. Okay, so how will we get minus 2? Okay, first of all, look at this term. You should get minus 2x over here. So you can multiply and divide by minus. Okay, so I will be having minus like this. Okay, and over here I will be having plus 5x plus 1 dx. Okay, so I was substituting it and then taking the derivative. I found this. Okay, so minus, so over here minus 2x, but you need minus 2x plus 5. So what I will do, I will just add over here plus 5 and then I will subtract minus 5, but also you still have this minus 1. Okay, minus 2x is here. I've added and subtracted 5 because I need minus 2x plus 5. And then I will be having this minus 1 right here. And the denominator does not change. It's still minus x squared plus 5x plus 1. Okay, dx. Okay, so this is what we are having. Now, what actually do we do? I will group this one together. Okay, because I need it. Okay, so minus 2x plus 5 upon root minus x squared plus 5x plus 1 dx. Okay, and the remaining, I will minus 5 minus 1 will give you minus 6, and over here you have a minus in front, so minus x squared plus 5x plus 1 dx. Okay, so this is what we are having. Over here we will do this substitution equals z. So over here will be changed into dz, and over here will be converted into root z. Over here we will keep it as it is. We won't do any substitution here. So this is what we are having. Okay, I'll just keep in mind that z is minus x squared plus 5x plus 1. Okay, keep that in mind. Maybe I will need it again. So now what actually will we do? If you see over here now, this one has been converted into dx by quadratic. Okay, so this one, it is of the form dx by quadratic. Okay, dx by quadratic, we need to complete the squares. Okay, so this one will change z power minus 1 by 2 dz. And over here, we will have to complete the squares, just like we did before. I will take common the minus sign, so we will be having x squared minus 5x minus 1. Okay, so the same procedure I will use, but over here I can easily integrate it. So these are very long problems. You just need to know the correct procedure of how to do them, and you won't be having any problem. Minus half plus 1, minus half plus 1, okay, plus 6. This one we can complete the squares. So over here we will be having, okay, minus x squared minus 2ab. Okay, it has to be 5, so I will write over here 5 by 2 plus 5 by 2 whole thing square minus 5 by 2 whole thing square, and then you are having minus 1. Okay, so that is what we are having. This one you can actually write it down as minus z power 1 by 2 upon 1 by 2 plus 6 dx. Just like we did before, we will combine by using the formula a minus b whole thing square. Okay, combine this one, and we will be having minus x minus 5 by 2 whole thing square. And if you combine these two, you will be having minus 25 by 4 minus 1, so minus 29 by 4. Okay, so you will be having minus 2 z power 1 by 2, that is root z, plus 6 dx upon square root, okay, 29 by 4 minus x minus 5 by 2 whole thing square. Okay, but 29 by 4, it can be written as root 29 upon 2 whole thing square. Okay, so now what do you need to do? You just see that it is similar to, again, to formula number 6. Okay, so you will need to use formula number 6. Okay, I will write it down. Minus 2 root z, it is that, minus x squared plus 5x plus 1 plus 6, and it is similar to formula number 6, which is sine inverse x, it is x minus 5 by 2 upon a, which is root 29 upon 2 plus c. Okay, you can do some simplification here, or you can leave it as it is. Okay, it's your choice. Okay, but this is the final result. Okay, so I hope you are clear, but just to be more clear, let us do another problem. Okay, maybe number 7. Okay, maybe problem number 4. Okay, where we are having linear, let us say 5x minus 1, and then we are having a quadratic, let us say 2x squared plus, okay, maybe 4x squared, 4x squared plus 2x plus 1. Okay, I will make it simple this time. Okay, 2x. Okay, let us do this. All right, I hope that it will be simpler. But since this one, it is linear, root quadratic. Okay, so if it is of that form, we will be needing to adjust by using the derivative of this quadratic. Okay, so firstly, let z, okay, take the quadratic, substitute it as z, now differentiate it, you will be having 8x plus 2 dx equal dz. Okay, we will adjust this term in the linear. So over here we will be needing 8x, right? So what can we do? We can multiply and divide by 8, or in other words, we can first take common 5. Okay, we will be having x minus 1 by 5. Okay, and over here we will leave it as it is. Now we will be needing 8, so we can multiply and divide by 8 because we need 8x here. Okay, multiply and divide by 8 minus 8 by 5. 4x squared plus 2x plus 1 dx. Now you see that we will be needing 8x plus 2 in the linear. So 5 by 8. I will just write over here 8x plus 2, and then I will subtract 2. But then this one will also be there. So this is what we are having. Next, okay, I will just write it like this. 8x plus 2, I will keep it as it is because that is what I will be needing. And over here I will combine them. You will be having minus 18 upon 5 root over 4x squared plus 2x plus 1 dx. Okay, so we always have to adjust by using the derivative of the quadratic whenever we are having those type 2 integrals. Next, okay, we can do this. Okay, combine this together. 5 by 8 integral 8x plus 2, and then we will be having this root quadratic 4x squared plus 2x plus 1 dx, but also we will be needing this term, so plus, okay, minus 5 by 8 18 by 5 18 by 5 root over 4x squared plus 2x plus 1, okay, integral dx. So that is what we are having. So over here what you will do, again in the first integral, you will use the substitution 5 by 8. So this one, it is substituted as z. 8x plus 2 dx, it is equal to dz. So you'll be having this. Over here you can do some cancellation. 2 9 to 4. So this one, if you see, it is actually root quadratic. Okay, whenever you are having only a quadratic or a root quadratic, you will always have to complete the squares. Okay, so over here you will be having 1 by 2 plus 2 plus 1, 1 by 2 plus 1. Now we will complete the squares. Okay, I will first take common 4 x squared plus 1 by 2x or x by 2 plus 1 by 4 dx. Okay, so this is what we are having. Z power 3 by 2, 3 by 2 minus 9 by 4. Square root 4, it is 2. Okay, so this is what I am having. X squared plus x by 2 plus 1 by 4 dx. Again, these problems are really long. So 5 by 8. Okay, I will do some simplification. Okay, 5 by 12. Okay, after simplifying, you will be having this. Okay, minus 9 by 2. Now complete the squares over here by using that formula a squared plus 2ab. You will be needing x by 2. So I will write over here 1 by 4. Okay, because if you multiply this one, you will be getting x by 2. So plus 1 by 4 whole thing square minus 1 by 4 whole thing square plus 1 by 4 dx. Okay, this one, okay, it will be 5 by 12. Okay, you can substitute that, or you can still write it here, then substitute it in the last stage. Now this one, you can actually write it as x plus 1 by 4 whole thing square. This one you can combine, so it will be minus 1 by 16 plus 1 by 4. So we'll be having plus 3 by 16. Which it's almost done. Okay, so you just need to write this one as root 3 upon 4 whole thing square. Okay, and if you see, now this one becomes like formula number, okay, formula number 8. Okay, if you see formula 8, so sorry, formula 7. Okay, x squared plus a squared. Okay, so we can use formula number 7, and then we will be, okay, use formula 7. Okay, I won't be completing it. Okay, but you can use formula number 7 for this one to complete it. Okay, and then you can also substitute the value of z that we had substituted. Okay, so that is about type 2 integrals. Okay, what about type 3? Type 3 also we will still be having quadratic. Okay, but this time, okay, the quadratic, it is in the denominator. Okay, let us see. Suppose we are having dx. Okay, this is actually different, linear, root linear. Okay, so we are having this type of integral, dx by linear, root linear. We are not having any quadratic. And this one we are having, suppose linear is in the denominator, linear root quadratic. Okay, before the linear was on top, but now linear is on the denominator. Okay, so for this, what shall we do? Okay, for this one we will substitute this second linear. Okay, maybe I will write it with a blue. Okay, so just to differentiate it. Okay, you are having two types of linear. Okay, the first linear which is black and the second linear which is blue. So substitute the blue one equal z square. Okay, and for this one, what actually will we do? We will substitute the black linear equal 1 by z. Okay, let us see some examples. Okay, number 1, integral dx, let us say 2x plus 1, and over here root over 5x plus 1. Okay, so over here it's a linear, and over here also it's a linear solution. We need to substitute the 1 under the root, so we will substitute 5x plus 1 equal z square. If you do this substitution, you will also be needing x. So 5x will give you z square minus 1, and you will be having this z square minus 1 upon 5. Okay, and if you differentiate it, you will be having 5 dx equal 2z dz. Okay, or dx, it will be 2z dz upon 5. Okay, so this is what we are having. So dx, it will be 2z dz upon 5. What about this 2x plus 1? Okay, we can use what this one. Okay, 2 times x, it is z square minus 1 upon 5 plus 1. Okay, 2x plus 1, and root over 5x plus 1, which is root z square. okay, dz. And this one, it's actually equal to, okay, 2 by 5, you can take it outside. So you will be having z dz. We can do some simplification over here. You will be having 2z squared minus 2 upon 5 plus 1. Root z squared will give you z, which you can cancel with the 1 on top. So you will be having 2 by 5 root over dz. Okay, and then I can do some simplification again. Okay, upon 5. So this 5 and this 5 will get cancelled. dz. Okay, so now if you see, it has actually been changed into dz by root quadratic. Okay, dz by quadratic. Okay, so now you will need to complete the squares. Okay, again, I won't do it. Okay, complete the squares, and then after completing the squares, like we had done before, okay, take common 2 and then use the formula. Okay, we don't need to complete the squares over here, just see. Okay, so we will be having dz. Okay, I will actually finish this one, 2z squared by 3. Okay, so 2. Again, you can take common out, take the 2 outside. So dz. Okay, I will complete it. I don't think it will take too long. So now we can cancel them. So we can write dz z squared plus root 3 by 2 whole thing square. If you see, this one, it is actually formula number 1. Okay, so formula number 1, it is a squared plus x squared. Okay, so you will be having 1 by a tan inverse z upon a. Okay, plus c tan inverse root 2 and z. Okay, it is actually root 5x plus 1. Okay, because you need only z upon root 3 plus c. Okay, so this is the final answer. Okay, for that first, for type 3. Okay, now let us do a problem of the second type. Type 3, but it is of this form. Okay, type 3 number 2. Okay, so suppose we are having dx. Okay, I'm just making the question on the spot only. So linear, it will be 2x plus 1. And root quadratic, suppose it is x squared plus x plus 1. Okay, so it is of this type, linear by quadratic. And if you see over here, we have to substitute linear equal 1 by z. Okay, so that is the first step. 2x plus 1 equal 1 by z. So again, over here, if you follow, it will be 1 by z minus 1. Okay, we need the value of x. 1 by z by z. So the value of x, it will be 1 by z upon 2z. But also we can differentiate it. If we differentiate it, we will be having 2 dx equal minus 1 by z squared dz. Okay, do the differentiation and you will be having this. Now, okay, we will be needing dz, dx, it will be minus dz upon 2z squared. Substitute it over here. So the integral dx, it will be minus dz by 2z squared. Okay, and over here you notice we will be having 2x plus 1, which is 1 by z, and we will be needing this square root, okay, which we can use the value from here, minus 1 by z by 2z whole thing square plus x will be minus 1 by z upon 2z plus 1. Okay, so minus 1 by 2, we can take outside minus and 2. So over here z square and z, one of them will get cancelled, so you'll be having only z. And this one, you can do the simplification. A minus b whole thing square will give you 1 minus 2z plus z square. 2z whole thing square will give you 4z square. 1 minus z upon 2z plus 1. So you will be having this. Now take common in the denominator 4z square, which is the LCM, and you will be having this. So 2z minus 4z square, okay, plus 2z. So this is what we will be having. So sorry, over here will be 2z square. Okay, 2z square over there. So over here we'll be having minus 1 by 2 dz. Okay, now we just need to do some simplification. Over here root 4z, okay, will be 2z. And then we will be having a root now only on the top. Okay, do some simplification. Okay, so we will be having z square minus 2z square. Okay, this one will actually be 4z square, so sorry. Okay, so I made a mistake. So over here will be 4. 5 minus 2 will be 3z square. 3z square plus 1. Okay, so this is what we will be having. 3z square plus 1. Okay. Now this 2 and this 2 will get cancelled. Z and Z will get cancelled. So we'll be having minus dz upon root over 3z square plus 1. We can take root 3 common. So we will be having only dz z square plus 1 by 3. Okay, the usual thing, dz, and over here we'll be having z square plus 1 by root 3 whole thing square. Now after doing this, you see that now it has been transformed into one of the types, which is formula number 4. Okay, so use formula number 4 and you will get the answer. Okay, maybe I'll write it down. Okay, since it's already the last step. Okay, if we see formula number 4, it is log. Now we will be needing x, but over here instead of x it is z plus root over z square plus a square. Okay, so this is what we are having. Now we just need to substitute z. Okay, z, okay, 2x plus 1, it's equal to 1 by z. So z, okay, multiply it here, you will be having 1 by 2x plus 1. 1 upon 2x plus 1 plus root over z square, which is 1 by 2x plus 1 whole thing square plus 1 by 3. Okay, so this is the final answer plus C. Okay, so what basically had we discussed over here? We had discussed about when we are having linear only quadratic or root quadratic, okay, either in the numerator or denominator. Then we had discussed when the linear is mixed with the quadratic, but the linear is upwards. Okay, that is the linear is present in the numerator, that is type 2. And type 3, it is when the linear is in the denominator. Until next time.